Hi friends, today I've brought a string gauging seminar. I represent a company called Recordtech Electronics, which is situated in Roorkee, Uttarakhand, and you can reach us by writing to us at sales@recordtech.com, or you can visit our website www.recordtech.com. So string gauges, they exist before me and many of us long time ago. This is one of the oldest measurement technique, and strain is a dimensionless quantity which we have all studied. And what we bring you is a solution from Japan, a company called TML, who are pioneers in strain gauge manufacturing. So the company Recordtech, a brief overview, it was started by Mr. Vijay Kumar, proprietor and founder, an engineer from IIT Roorkee, which was then University of Roorkee, an eminent engineer with over 4 decades of experience in strain gauging and measuring of different physical quantities, which can be anything like strain, pressure, load, or temperature. So in this session, I would give you a brief overview on some nomenclature, strain measurement techniques, typical theory definitions, and then how to select a strain gauge. And then we can have a follow-up session where I can give you something about how to install the gauges. About our company, we have a very focused mission that we provide solutions to the measurement needs, that is your needs. The voice of customer is captured, and based on that we bring in various solutions across the world, which suits in optimized way to the application which you have. So if I go back to history, an idea which was conceived in 1936 was actually converted into a commercialized strain gauge in 1937 by Arthur C. Rook, and you can actually Google him and study about him, that how he eventually came up with strain gauges. So we as an electronic a company, we have a very strict policy about how we document, and that's why we call them as artifacts, very stringent in the quality management system, which is a key strength of our company. So now getting to the actual parts of this session, strain gauge nomenclature. Why this is important? Because we all know what a strain gauge looks like, or many of us know how it looks like, but do we really know what we have, how we have to see a strain gauge? So this is a typical picture of a strain gauge. Now on the left top, this circle, you can see there is an image etched which says the company's name, a logo. Usually if there is other brands, then this logo may differ. Then this is the gauge pattern in the center, which we say overall gauge pattern length, okay, and the gauge width. So this is then we have the end loops and the transition loops and the solder tabs, from where the leads, soldered leads are coming out. The color, if you can see, that's enameled, so that we don't have shorting, and these are outer grids which are thicker and the inner grids. And what actually matters is gauge length. This is the gauge length. So usually if we are asking for a gauge, we usually specify I need a 1 mm gauge or a 2 mm gauge, and that is the gauge length. Now if we have a pre-wired gauge, then there will be this enameled lead wires connected to a cable, and the cable can be as per the choice of the user. Then the practitioner's approach, why I say this is that the things which we practice, and there is a theory behind it, and this is just brief recap of our 11th and 12th standard physics, which we have all studied. F is equal to mg, where g is 9.81 meter per second square, and I think most of us would remember that the explanation in a lot of books in physics, that a man weighing 50 kg, about 110 lbs, would actually weigh 42 lbs on Mars. And so this experiment, this used to be there in the illustration. Very important thing. So we should always remember about these things. Then, what is the type of strength? In engineering, the term strength is always defined and is mostly one of the following: compressive strength, tensile strength, shear strength, and torsion. So, and these are all dependent on type of loading. So, let me give you a brief overview of all these things. So, by formula, stress is what? Load by area. That's the definition, and that's the formula. So, stress is measure of internal resistance in a material to an external applied load for direct compressive or tensile. So, if somebody is bothering or somebody is bothered by these two words, compressive and tensile, in a simple way, if you take a scale and you try to press it, bending, if it starts bending inwards, then it is almost like a compressive strength. When your both hands come towards each other, it's compressive. When they go outwards, that is tensile. So this was like when I am in horizontal plane. When I am in vertical, anything hanging and you are taking again both hands going, one going up and one going down, that's tensile. Both hands coming together is compressive. Shear. Shear. Similarly, in shear stress, the shear stress is tau, and the symbol tau is measure of internal resistance of a material to an external applied shear load. Shear stress is defined as load upon area of resisting shear. So, if and the picture is, I think, self-explanatory. The force is at one end, and it is this is a shear force. And I think these three pictures actually give you a very clear idea on the left hand side when we are taking this apart. So these are the hands going outwards, so it breaks in between because of the tensional force. When it is coming towards each other, it's compression. When they are actually rubbing each other, going in opposite directions, then it is shear. On the right hand side, I have shown an example of what a torsion stress would be, or a bending stress, flexion bending stress, when it is simply supported beam by 2 points and a force is applied in between. So in this picture, if we see this particular picture, we have a bridge and there are different members in the bridge. Some of the members are in tension and some of them are in compression. So this is a typical theory of ultimate strength. So I think the formula says it all. Safety factor is equal to stress at failure upon stress when loaded. So ultimate stress upon permissible stress. So now let's start defining strain. What is strain? Strain, as I said, it's a dimensionless quantity, is increase in length by original length. And shear strain is shear displacement x divided by width L. So I'm not reading the specific definitions, it's pretty explanatory. Now elastic and plastic deformation. So when we this is a very, again, like I will take the scale example. If I start bending a plastic scale, okay, here the plastic word is from the material plastic. Now if I start bending it to a point, if I release, it would come back and attain its original position. So that means it's elastic. We have elastopolymers and different kind of rubber bands which are elastic. You stretch them, you release, and they come back to their original shape. But after a point, which is usually called as a yield point, it would not come to the original position, and that is where it's called deformation. And after another point, which is a rupture point, it will actually break or start breaking. So material. So, as in physics, elasticity is the ability of the body to resist a distortion, influence, distorting influence, and to return to its original size and shape when the influence or force is removed. Whereas for plastic, it would be opposite. So this is a typical curve for steel and how energy is absorbed, strain versus stress curve. Now let us start talking about measurement. How do we measure stresses and strains? The general strain measurement procedure is very simple. We determine what is to be measured, measurement purpose, requirement, accuracy, etc. Survey the measurement condition of material, shape, dimension, temperature, atmosphere, because for different temperature we need different kind of gauges. Select the strain gauges. Selection of the strain gauge, adhesive, lead wires, coating material, all of that has to be decided. And plan out installation procedure. So usually if you have an installation procedure, it is good because you need some drawing how to do it. And then install the strain gauge, then measure the strain, process the data, check the validity of data, remove the strain gauge and clean up. So these are just very basically explained the general procedure for measurement. Now it is very important for an individual to actually select the correct strain gauge, and when you are selecting, I have identified 4 limitations sections which you should always consider. When you want to use a heat curing adhesive but heating the test specimen is problematic, this is one limitation you should always take care. When you should when you want to use a weldable strain gauge but test specimen material is difficult to weld. Third is when the amount of coating required to waterproof the gauge causes structural problems with gauge functioning. And fourth, if there is any other constraint which I may have left in first three, then those would fall in limitation 4. And the results, what you measure, will be defined by how you have selected the gauge, how you have installed it, and what is the accuracy of the system. So every building block in the measurement would contribute to the authenticity of the data which you acquire. Now, type of strain gauges. So if I have to classify, we can say testing temperature is one type of criteria: low temperature, normal, high, super high. Then usage, large elongation, stress concentration, residual stress, bolt axial, torque, etc. Then what is the material you have to use? That is metal, concrete, wood, plastic, composite materials, glass. So you have to decide on what is the material. So when I say metal, it can be MS or SS, or it can be aluminum. Then there are transducer specific, because when you're making a load cell, then you need strain gauges which are designed for transducer. Size of the strain gauge is very important. Now in the earlier slide I have shown gauge length. So gauge length is very important. So if I have to break, I have broken the entire lens into 4 sections, 0.2 to 1 mm with the smaller ones, and 2 to 6, and then 10 to 20, and 30 to 120 mm gauge lengths. This is a very important criteria which one should always consider depending on the specimen or the material on which you have to place the gauge. So now for stress concentration measurement, we have 0.2 to 1 for wooden mortar, FRP materials 10 to 20. For metals usually it is 2 to 6, and for concrete it is 30 to 120. But you should always check with us what exactly is your specimen and what you want to do, and we would let you know the right kind of gauge. So we even have some narrow type gauges which are marked with FLK, so they are narrower in width. Now, gauge pattern. Gauge pattern is important because we don't know the principal axis of stresses or strain. So we have uniaxial, we have two element rosette, then we have two element rosette. One is stacked, one is plain type, then three element, stacked and plain, and then we have five or multiple element gauges. So we have to know what you should always decide on what pattern you should choose. And this is not there are multiple more patterns of strain gauges which are there for different application. Now, temperature is very important because temperature variation would give you different results, so you need to select a gauge which is compensated for the temperature. So there are strain gauges for cryogenic range where minus 269 degrees to room temperature. We have a standard range which is minus 20 to 80, and then we have high temperature range up to minus 20 to 200 and up to 300, and then we have super high category which is up to 800 degrees Celsius. Now, so the criteria is testing temperatures, select item selected is gauge series, and method is select a gauge series capable of functioning at the testing temperature. Test specimen material, self test compensated strain gauge, select the appropriate self temperature compensated strain gauge for specimen material. So this is a basic slide of use this table below as a guide to select strain gauge for ordinary strain measurement. Now, basic strain gauge installation procedure step by step: surface preparation, strain gauge installation, adhesive curing, strain gauge installation check, lead wire connection, coating, and final check. So these are the steps which are done. Then so basically I've covered most of the topics in an overview mechanism. I understand this is a brief course or intro how a strain gauge is selected and how it will be installed. More information you can find on other videos, or you can write back to us and we can let you know how to do this installation. You can always reach us through our website, a responsive website, and we have a website which can help you. A parametric search is there which can help you select a strain gauge, find a part number, and then you can ask a quotation from us. So this site needs registration. If you don't have a registration, you can use the username and password from us. You can ask us and we'll provide you that, and you can do that. Otherwise it needs a quick registration, and it's very simple. You just click on strain, you find parametric search is there. You can select the range of temperature you want to do the experiment with, and you can find your gauge. And you can even search us through your mobile phones. Our site is very responsive. And if you want to write to us, you can write to us at salesrecordtech.com, admin@recordtech.com, or you can call us on the given numbers. Thank you. We are a company which is presently working in the entire country and Indian subcontinent, and we are located up north. So in our website, if you want to come to our office, there is an instruction given on our website. Please follow that, and you are most welcome to visit us in Roorkee. And we represent a Japanese company, and the quality is well trusted from Japan. Thank you. Have a great day.